Hoping that all of my chats audio's way over here. Can mute this, can mute this. Hopefully the YouTube TikTok chat. Okay, so TikTok chat is up. All right, I think I have everything up. Okay, let me make this smaller. This smaller. Sorry, y'all, give me just a second. Trying a new setup for this live stream. Okay, there are a lot of questions coming in. We will do our best to answer as many as we can from as many sources as possible. So, hopefully the audio is coming through clean. And oh, I should send out announcements really quick. Sorry, we will start in just a mo. There we go. Now we're all set. Right. Okay. Can you explain the Lindhard Sorensen effect? Yeah. So and I made a video on this a long time ago. If you've seen the needle passing through the Earth video, this is what it's related to. The Lindhard Sorensen effect is basically if you have something with sufficiently much energy, like if you have a particle with like enough energy, it can only dump a certain amount of energy to the particles around it. And it's essentially like there's not a whole lot to explain. It basically falls out of the math. You can kind of think of it as it has so much momentum that there's just that like something stationary can only grab so much. That's the way to think about it. Can you explain why plastiline is not so good as they claim to be? Well, the issue is that producing it is really, really dirty, right? That's the primary issue. Now, just a quick question, what is the best theory of time currently? Well, most physicists work given the B theory of time. That's just like what most physicists work in the context of, but you know, whether that's the best or not is a different question. What evidence do you personally find most convincing for dark? Oh, you know what I could be doing? I could be highlighting the questions that I'm answering. That's really, really good. So what evidence, no, actually, no, I won't do that because that should be reserved for super chats. What evidence do you find most convincing for dark matter? There's basically 3 or 4 pieces of kind of evidence that I'll link together. The first is that the galaxy rotation curves, that's the thing that got us thinking about dark matter in the first place, that galaxies are rotating faster than they should be given the mass that we can see. Then there's the fact that we can see gravitational lensing, right? We can see the gravitational lensing of more mass than what we can observe. So you can see light being bent around heavy things, but sometimes we see light bending more than it should given the amount of stuff that we see. So that implies that there's more mass there than we can see dark matter. Then there's the idea that if you look at the cosmic microwave background radiation, it seems like in order for the data that we have from that to make sense, there needs to be a certain amount of mass in the universe, and that's just more than what we can actually see. So it all kind of like lines up together to make something nice. Dark matter someday usable to us? Almost certainly not. The reason why it's dark is because it doesn't interact via the electromagnetic force. And considering that all of our tech relies on the electromagnetic force, almost certainly would never be useful. What's the difference between antimatter and dark matter? Antimatter we can see, antimatter we can make, antimatter we can detect. Dark matter, completely different thing. Antimatter is just like regular matter, but the opposite. What would it take for the replicator in Star Trek TNG to be real? Basically just some, like, just really high, really fine control over particle accelerators, basically. That's essentially it. Can we compare the evidence from DESI about a big crunch versus the commonly accepted big freeze? So DESI doesn't point to the big crunch. What DESI does point to is it weakens the evidence for the big freeze, also known as the heat death. So what DESI is saying, the evidence that we have from DESI indicates that that dark energy is getting weaker, that it used to be stronger in the past, so it's force causing our universe to expand at an ever accelerating rate. it was bigger in the past, and now it's getting weaker, so the acceleration is getting smaller. Now, if you follow that through, just do a linear interpolation, eventually what you'll find is you'll get some sort of recollapse. But that's assuming a lot of things, right? Like, we don't know if, like, why should it be linear, right? Do you think modified gravity could ever replace dark matter? No, even the best theories of modified gravity have some dark matter, they just have less. Do you understand Rick and Morty? Well, it's a cartoon and it's science fiction, so most of it doesn't really make sense. Would you believe, what do you believe to be the most plausible outcome for the universe to end? Big crunch, or I'm agnostic at this point. I think that there are a lot of options that are now on the table that we have to deal with. And from Jeffrey, we have, can you explain the shape of the universe result? So the shape of the universe, what we're really talking about is how curved is each three-dimensional spatial slice of the universe. So our universe is 3 dimensions of space, 1 dimension of time. If you take a moment of time, the question is, how curved is it on average? How curved is it intrinsically? Now, we know that, like, mass curves space-time, right? The question is not, like, what is the mass doing? The question is, if there was no matter at all, what shape would it be? Would it have curvature or would it not? Because in principle, it could just have curvature on its own. Like, for example, if each spatial slice was like the surface of a sphere but 3-dimensional, then it would have curvature. And so what we're really asking about is the intrinsic curvature of the spatial slice of the universe. And it turns out when you go and you try to measure that, what you find is that it's basically 0. The curvature is basically 0, which means that in some sense it's flat. It's like a 2D sheet of paper rather than like a 2D, rather than the surface of a sphere, but 3-dimensional. Is there something further than the observable universe? Most people think probably. If only because the observable universe, it would be very, very weird if the observable universe was a hard cutoff, right? Do we really need, what was that question? Do we really need time in physics? Well, in some sense, yeah. It doesn't have to be fundamental, but it definitely needs to be there. Otherwise, we can't have evolution equations. We can't have differential equations that tell you how things change. Can we destroy energy and why? Well, we can't. But what we can do is we can observe energy being lost. So if you shoot out a light beam into space and it travels for billions upon billions of years without running into anything, it will lose energy over time, right? Because the universe is expanding, those light waves are stretching, and stretched light waves have less energy than, oh, is the super chat supposed to stay there? No, oops, I forgot to get rid of it. If the light waves stretch, then that means that they're losing energy, and that energy doesn't go anywhere. Is Bill Nye an intellectually honest scientist? Well, he's not a scientist. He got a degree in civil engineering or mechanical engineering, and he's a science communicator, a science popularizer. And in that respect, I think he does a very good job. Why do you think dark matter hasn't been directly detected yet? That's a good question. I suspect it's merely because it's very, very hard to detect. Outside the observable universe, what do you think there is? Maybe just dark matter? It's almost certain. It almost certainly is just like more regular matter, just that we can't see yet. Debunk, are we living in a simulation? I already have a video on that, but essentially the original justification for the thought experiment that we live in a simulation is merely that it seemed plausible at the time that we could eventually create a simulation of our universe like us. But now we know that that's not possible. There are like information theoretic reasons why you can't do that, physics reasons why you can't do that, and so it's not really well evidenced, it's not really well supported anymore. Thoughts on quantum tunneling? It's cool. Who should I listen to get into physics? Who are the best communicators? PBS spacetime is probably the best. Why do you think that the definition of scientist is someone with a science degree? Why don't you say that anybody who practices a scientific method is a scientist? I don't think it requires a science degree. I think it requires it to be your occupation. Scientist is an occupation, much like doctor or engineer is an occupation. If you work as a scientist, as in that is a way that you spend a big chunk of your time doing science, then you're a scientist. Now, most of the people who are doing that have science degrees, because most of the time it doesn't pay the bills. Most of the time people can't support themselves while also spending 5 to 8 hours a day doing science. So it's just a matter of most people who end up doing this do have science degrees. And generally people who claim to be scientists who don't have science degrees, you can tell very, very quickly if they're talking out their ass. The lost energy of those photons isn't transferred into space somehow? No, it's not. It's just gone. What do you think of the Nobel Prize winners for physics? I think it was a really good choice for the prize. I mean, perhaps there are better choices this year, but I think that they definitely deserve it. They did some very, very excellent physics back in the 80s. Go watch my video on it. Do you think we'll ever achieve 0 Kelvin? No, that's the third law of thermodynamics, that you can't do that, that it takes an infinite number of steps to do so. How many stars does a black hole in the center of the Milky Way consume per year? Probably none. We would see it if it did, right? Will we ever fully understand what dark matter is, in your opinion? If we detect it, then yes, but if we never detect it, then no. And if we never detect it, then maybe it's just not real. How often do you spend time mixing liquids in beakers? I never do. So you mean that if you don't have a science degree, you're not a scientist? No, I didn't say that. I said if you don't spend your time doing science, if science is not your occupation, then you're not a scientist, right? What do you think about time? I think that time is something that exists, but is emergent. What are the challenges of dissipating excessive heat from, say, a space station? It seems like it should be easy. Oh, well, the issue is, let me put it back up. The issue is that there's no way to conduct heat away from the space station. There's no way to convect heat away from the space station. The only way you can do it is radiate. So the way that we get heat away from things generally is you like put a cold thing next to it, and then the cold thing will grab some of the heat from the hot thing. Or you blow air over it, or you flow water over it to grab the heat from the hot thing and take it away. In space, there is no something, you can't put the space station next to something to get the heat away. You can't blow air over it to take the heat away. It just has to radiate it away. In the same way that like a red hot piece of iron glows red and loses energy that way, you have to radiate away the excess heat of a space station, and that's tricky. Is it true that cold doesn't exist? It's just taking heat away? Cold is it's just like an adjective, right? It just describes things that have a low temperature. What's your opinion on the possibility of time travel going forward, because backwards isn't possible? Yeah, we are going forward in time right now, right? Do you think 2D sees 1D the way we see 2D, and then like 4D? Well, I don't think that there are 2D things. I don't think that there are 4D things. I don't think that we have really any evidence that that's the case. What's your favorite part of physics? It's gotta be relativity. Relativity is beautiful. It's beautiful, and it's really simple, like conceptually. Would you be willing to discuss theoretical science for a novel I'm writing, bio-quantum fields? I don't know much about bio to begin with, and also generally my time is so I'm so booked. I'm so busy, so I'll have to pass. What do you think about 3i Atlas? Go watch my playlist on 3i Atlas. It's a comet. Do you think that gravity is constant regardless of the direction of travel? I don't know what you mean by constant regardless of the direction of travel. Gravity is like a well-described force that seems to be the same everywhere in the universe. What's your take on multidimensional theory? I don't think it's a theory. It's just like a shower thought. From a POV of an external observer, could a particle manage to enter a singularity of a black hole? No. No. You will never observe a particle cross the event horizon. From MILF Wrangler with the $10, thank you so much. How do we know our universe is three-dimensional when math has significantly more than 3? Could it be that we just can't perceive it? Well, yeah, sure. However, there are features of our universe, like the inverse square law, that point to even the things that govern the forces of our universe, like electromagnetism, like gravity. These things also only live in 3 dimensions. Now, it could be that there's extra dimensions and just nothing interacts with them, but then in what sense do they exist? If TikTok can't see our comments, why do we have to endure theirs? I can't figure out a way. I guess I could maybe get a way for TikTok to see it, but vertical people can't see your comments either. What's your favorite fact? Can be anything science related. That gravity isn't always attractive. It's just that's the most typical case. Do you find it amazing LIGO detects movement less than the size of a proton? I absolutely do. LIGO is an incredible feat of engineering and physics. Any preferred quantum mechanics interpretation? Is superposition real? Can there be macro superposition? Superposition does seem to be real, and I prefer the many worlds interpretation. Can there be macro superposition? Probably not with a cat. Quantum mechanics doesn't like hot, big, or wet, and cats are kind of all of those things. So probably not with a cat, but you could in principle build something that's in a quantum superposition as long as it's isolated sufficiently well, like something like the size of a human hair or something. Okay, you can't just drop a gravity isn't always attractive and then drive away. Yeah, okay, so first of all, dark energy is an example of non-attractive gravity, right? But secondly, if you have a spinning black hole, right, spinning about an axis, and then you drop something onto it that's also spinning about an axis, the same axis, just perhaps in the opposite direction. I always get the direction backwards. If the black hole and the object are both spinning fast enough, then the black hole can actually repel the object. Can you explain what created the matter that caused the Big Bang? Matter didn't cause the Big Bang. Rather, the Big Bang was a rapid expansion of our universe, and there was matter involved. Like, there's just matter there. Now, the question is, what caused the rapid expansion? We don't know at this point. The mainstream answer is inflation. If someone is traveling at 0.9 c from me and they step on a scale, would they weigh heavier than me? If they step on a scale, like, in their own reference frame, no, they would weigh, I mean, they would just weigh what they normally weigh. How can it repel the object? That's just what the equations of gravity say. It's because of the angular momentum stuff. If decoherence explains things looking classical, what decides which outcome is real in measurement? Well, that's the question, right? So under the many worlds interpretation, all outcomes are real. Under the Copenhagen interpretation, it's just genuinely random. Do you subscribe to the idea of universe from nothing? No. Why does everyone bring up string theory, especially when talking of multiverse? Well, the string theory naturally proposes or naturally predicts a multiverse because there's something called the string landscape, which is the all of the possible ways that the string vacuum could be. And if you say that each string vacuum can be realized independently, then you genuinely have a multiverse. But that is only if string theory is true, right? Yeah, by the way, if you want to get your, so there are a lot of questions. I'm taking questions from three different live streams right now. If you want to ensure that your question gets answered, the best way to do so, either fortunately or unfortunately, is by sending a super chat. And if you want to watch in the horizontal, you have to go to the Dr. Blitz debunks page. It's not on the main YouTube page. Right. Do you think that our universe affects other universes? I don't think that there are other universes. At least I'm not convinced that there are. Can you explain how light can have mass? How can light have momentum? Well, light doesn't have mass. It does have momentum, but that's just because momentum is not mass times velocity. That's only true at low speeds, but light is definitely not traveling at a low speed. Why do magnets affect iron and not other elements? Well, they do affect other elements. They also affect nickel and they affect chromium. Sorry, cobalt, not chromium. And that's just because those are the only pure elements that are ferromagnetic. In fact, magnets affect everything. Things are either ferromagnetic, like iron, nickel, and cobalt. Things are or diamagnetic or paramagnetic. Now, diamagnetic and paramagnetic basically just mean that it either is weakly attracted, but it doesn't become magnetic itself, or it's weakly repelled, but it doesn't become magnetic itself. How does the double slit experiment exist? Why can't we explain it? We can explain it. I don't know what you mean by how it exists. It's absolutely explainable using standard quantum mechanics. Essentially, all you're doing is you're interacting with it, so you're breaking the ability for the two different branches of the wave function to interfere with each other, because you're distinguishing between them. And the only way that you can get interference is if you have identical pieces of the identical contributions to the wave function. Okay. Are there any ongoing studies for new particles like the graviton? Well, there are people trying to figure out how we might, in principle, study or try to discover the graviton, but this is still very much in the realm of theory because the instruments would be absurd. But we're still working on it. And then there's a whole bunch of other particles that people are working on talking about, like glue balls and pentaquarks and things like this. How do you explain the rotation of galaxies? Galaxies rotate because of angular momentum conservation. They are planar because of angular momentum conservation. If TikTok can't see our comments, why do we have to endure theirs? Asking for a friend. Look, I assume that you just want to see all of the comments possible, right? So, how am I? I'm doing okay. Could dark energy equate to the mass energy that is being consumed by every black hole in the universe, a singularity being an entry into another dimension that causes expansion? As far as I can tell, there's no working models that show that dark energy is related to black holes. I know that there's a proposal for that a while ago, but nobody's really taking it seriously because they kind of basically used one data set and like they're not accounting for all of the other data that we have. What is the Planck length? The Planck length is the natural length scale of our universe once you incorporate gravity, gravity, and quantum mechanics. So the gravitational force involves masses and distances. Quantum mechanics involves, well, let me back up. So there are basically a few different constants in our universe, right? There's the Planck constant, which has units of joules times seconds. This is a very, very small number. There's the gravitational constant, which has units of newtons meters squared per kilogram squared. And then there's the speed of light, which has units of meters per second. Then there's the Boltzmann constant, which has units of joules per Kelvin. There's a whole bunch of different constants. And the point is these are kind of natural scales. These kind of set the natural scales of our universe, and you can combine them in a way to get a distance. That's what the Planck length is. The Planck length is kind of the natural distance once you account for all of the features of our universe. It just happens to be very small. And it happens to also be the scale where we start to expect quantum gravity to play a role, because it's where gravity and quantum mechanics are both relevant. We have a super chat from Displaced Gamer. Can you explain retrocausation? I don't see any issue with time flowing in either direction. And if time flowed in the opposite direction than it is now, I don't see any issue in the causal sequence. So the whole business with retrocausation is merely that we don't expect things in the future to affect things in the past. There's not like a philosophical issue. I mean, maybe you'll have a philosophical issue with it. It's just that like this is not something that like we generally expect future time travel to be possible, backward time travel to be impossible, just on the grounds of, you know, causality being preserved. Like we generally like the notion of causality, that like namely that things stay within their light cones and so on. So there's just a lot of good reasons as to think that retrocausation isn't a thing. I mean, like you can produce a theory with it, but you will find that it's super, super pathological. And the reason I say that is because you won't be able to like solve initial value problems and things like this. You won't be able to predict the future based on the past. Are you familiar with Jacob Barandi's work? No, I'm not. What evidence could decisively distinguish modified gravity from dark matter explanations? Well, look, so the thing is every time a modified gravity explanation it gets falsified, somebody comes up with a new modified gravity that evades the falsification. So I guess if we detected dark matter, that would do it, right? Can mass be negative? As far as we can tell, no. This is not like well, okay, so like in principle it could be, but we don't have any reason to think that anything is, right? Could the singularity be a hallucination of the math? Is there a greater density than the neutron star? The singularity probably is a hallucination of the math, insofar as it's a prediction. Like the math is fine, but all it implies is that the physics that we use to get the physics that implied that math is probably just wrong at that scale. Is metaphysics just a bunch of bullshit? Some of it is. I wouldn't say all of it is. Could the universe have always existed? Sure. Are you sure you don't see any special relationship between life and entropy? Yeah. What does it mean for space and time to be one thing? Well, it just means that they're kind of like intertwined with each other. You can, in some sense, rotate one into the other. That's what moving through space-time is like doing a space-time rotation. It makes your time move slower, it makes your distances contract. So if a warp field expands the space behind the ship and contracts the space in front, could it be possible that the expanded space does not contract fully? I don't understand the question. What major scientific discovery or achievement do you expect to see in your lifetime? Oh, I can't predict the future like that. How does the Big Bang align with the law of energy conservation if energy can't be created? The Big Bang doesn't say anything about where the energy for the Big Bang came from. It's silent about that. Is there any reason to try to get more precise than electron microscope? Anything we want to observe? Oh, we can see things smaller that electron microscopes can't. Like, that's what particle accelerators are. They're essentially more sophisticated electron microscopes. Can you explain entanglement, please? Yeah, so entanglement is basically this idea that there's a non-trivial correlation between two things, or there can be a non-trivial correlation between two things, even if they're spatially separated. So for example, you can have a particle that's in a superposition of being up and down, meaning that if you measured it, you'd have a 50-50 chance of it being measured up, 50-50 chance of it being measured, or a 50% chance of measuring it down. But that particle can be entangled with another particle that has a superposition in the opposite direction. So if you measure up on one, you'll know that the other one would always be measured down. Now, you can't send information this way because you can't tell if it's been measured yet. You can't tell if you measured down because the other one measured up or just because you happen to measure down. But entanglement is basically a way of describing a correlation between quantum systems that can be in superposition. Deal is with quantum gravity. Why the fine structure constant doesn't show up in classical electromagnetism? Because it has the Planck constant involved. Do you think it's possible for human intervention to influence the life cycle of a star if we had the means to do it? I mean, it's in principle possible, like by chucking a bunch of stuff onto a star or something like that, but not practically in the near future. From Fancy's Ling with the $10, if matter is an excitation of the particle field by the rapid deposit of energy into it, is it possible for there to be an infinite amount of matter in the universe, as in there's no max number of matter? Well, yeah, I mean, like, look, the universe might be infinitely large, in which case you could just have an infinite amount of matter currently, right? Yeah, there's no reason why that couldn't be an infinite amount. It's just, it would require that the universe is infinitely large. What is the triple point of matter? Well, so triple points are of a substance. A triple point of a substance is the temperature and pressure where the solid, liquid, and gas states can all coexist. The triple point of water is at around 0 degrees Celsius and also at a much lower pressure, if I remember correctly. Is there anything at the end of the universe? As far as we can tell, there isn't an end of the universe. Most handsome physicist right now, Yannick Herfray. Just look him up. Yannick Herfray. The dude is like a model. What do you think about 3i Atlas interstellar object? It's a comet. Go watch my 3 videos on it in my 3i Atlas playlist. And from Displaced Gamer with the $10, thank you so much. If the local universe is what is being expanded and not the greater universe as a whole, does this have an effect on entropy as the system isn't closed in the local sense? Oh, well, the idea is that the universe as a whole is what's expanding. That's the idea here. But if you're saying, okay, suppose just the local universe is expanding, just the observable universe is expanding, well, then what? Well, you could still talk about the entropy of the universe of the local universe, I suppose. It would still be increasing. Do we need to donate to ask questions? No, you just gotta ask questions that I see. Although super chats do get priority. That's definitely true. From Michael O, metaphysics moves towards bullshit based on the distance between it and an armchair. Yes, that's true. Yeah. Can the second law of thermodynamics work with an infinite universe? Sure. The second law of thermodynamics talks about systems, right? So you can still talk about the second law of thermodynamics of a system. Now, the total entropy of an infinite universe might be infinite. That's a harder question. Hermenneutics, that's a great name with the $5, asks, daily tied for the dog water question, who's winning in a fight, Ed Witten versus Alan Guth, physics versus chemistry, Blitz versus Ian? Ed Witten's younger, but he also seems meeker. I don't know. So maybe Alan Guth, physics, bodies, chemistry all day, every day. And I think I have reach on Ian. I'm like 7'8", and Ian is like 4'11". So I think I would win against Ian just for that reason. Why are Newtonian laws not fully true? Like, what does that mean? Which law? Well, what it means is that, like, things like momentum is not just mass times velocity. That's what's implied by Newtonian mechanics, and that's just not the case. That's what special relativity gives us. And then there's statements about, like, what is the then, like, the whole framework of Newtonian mechanics, that, like, an object has a definite position. That's not a correct framework if we trust quantum mechanics, for example. No lie detected, i.e. Yannick. Yeah, Yannick Herfray is a very, very handsome physicist. How do I super chat? It's actually not currently enabled on... I actually don't know if it's currently enabled. Let me go double check my account, because on the alt account, on the second channel, it might not be enabled yet. But we're trying to get there. So if you do want to send a super chat, go over to the vertical stream for a bit and then send one, and you know, I'll answer your question regardless. Yeah, you can also send cash apps with questions, and I'll answer those too. Juno sends $6.66. Hail Satan, Juno. For the message, it's pulling up right now. For the message, I can just pull it up on my computer, I guess. For the message, for a coffee. Okay, well, thank you very much, Juno. I'm going to make coffee at home, but I'll still eat coffee. What does it mean for matter mass to be conserved and converted into energy? Is it not destruction of the matter? Look, so matter is not energy, matter is not mass. Matter is something with mass, it's something with energy. Now, you can change, matter is like not conserved at all. Like matter conservation just doesn't hold. You can destroy matter, you can create matter. There's no issue there. You can change matter, all sorts of things that you can do. The question then is what's the relationship between mass and energy? Now, mass is related to energy. Mass is roughly the energy of a stationary thing. And so that is the outside of external influences, I should say. That's what mass is. And mass and energy are closely related. But matter's just like the substance. It's not a property. Now, we have a super chat from Angelo Garuso. In reference to the double slit experiment, can you please explain how observing a photon stream stops it from creating an interference pattern? Thanks and love your content. Yeah, so it's nothing to do with observing. So when you want to figure out which slit the photon went through, you have to do something to it. You have to, you could entangle it with something via like some sort of nonlinear crystal, or you could, put a magnetic field detector under one of the slits but not under the other, or you could put a camera in the way or something like this, or you could block one of the slits. The point is whatever you're doing, you are distinguishing between you are causing the state of the photon traveling through the left slit to not be able to interact with the state of the photon traveling through the right slit, because they are now decoupled. They're now linked with some other feature of the universe, whether they're entangled with something, and so the entanglement captures their distinction, or you have a magnetic field, so now they're entangled with the magnetic field, and the magnetic field is now connected to a dial. Whatever it is, you're now distinguishing between the two, however you're figuring out which one it goes through. And because they're now distinct, they're just not the same type of wave anymore. They don't live in the same space, so they can't overlap and cancel out. It's not enabled on the horizontal stream. Yeah, it's not enabled there yet. We're trying to get it enabled. We need another 2,000 hours or so of watch time on the horizontal stream, and then we'll have it enabled. So give it a week or two, and stick on this stream, so that way then we can get closer to that number. Is it possible to go back and see if there was an extra star in the sky? For argument's sake, let's say God exists. When baby Jesus was born, God put a star in the sky to guide the wise men. How long before the birth of Jesus did God place the star? 2, is it possible to go back and see if there was an extra star in the sky? Yeah, so the point is we have astronomical records. We can just double check and see if there was, like stars don't just appear, right? So I don't know how we would check besides going back there, or alternatively, you can just look at the stars today and you see that there's like nothing that would have happened that would have made it appear that there's a separate star. And yes, I'm aware that there's no super chats on the horizontal stream. It's not, the channel's not monetized yet. We're working on it. Now from Thomas to Captain asks, have you seen the quantum tunneling that recently won a Nobel Prize? And if so, could you help explain it to someone who doesn't have a physics background, give your opinion on it? I posted a video on it on TikTok, precisely on that topic. But essentially what they did is they created the first artificial atom. It's a little bit thinner than a human hair, a little bit smaller than the width of a human hair. And what they did is they used something called a superconducting tunneling Josephson junction. And they took a classical macroscopic, or they took a macroscopic variable, which is something related to the rate at which current can flow across the junction. So it's like an electronic device. So you have a rate at which current can flow across the junction. There's a variable that controls that rate. And what they showed is that variable, when the junction is sufficiently cold, that variable takes on discrete energy levels, and it can tunnel. So what we have is we have a macroscopic thing. In this case, this is the Josephson junction phase difference. Becomes a quantum variable. It behaves like a quantum system. It's discrete. It can tunnel, etc. Now we have from Gretchen Z with the $3.11. Come watch horizontal to get this thing monetized. Stat. Yes, absolutely. Go do that. We're working on it. Hopefully we can get it monetized ASAP. But we need 3,000 hours of view time, and that takes a little bit of time for a new channel. That is. From Busted Anomaly. Does before the Big Bang have a meaning? If so, how would it be described? It might. If there was no singularity, which is plausible, then it might make sense to talk about what the time was doing before that, right? I wish Carl Sagan were still alive. He would have some great live streams. I agree. He absolutely would. Now, from Fear's interaction with the $5, have the big brain scientists looking for dark matter even thought to use a flashlight? True. Go get your Nobel Prize, Fear's interaction. And from Angelo Geruso with the $5, thanks for the answer. Just showing some extra support. I appreciate that. All right. What's horizontal? So on my YouTube channel, Dr. Blitz Debunks, you can go watch the live stream in horizontal. That's all I'm saying. In fact, let me paste some links. Let me paste a link in the chat. So if you want to watch it horizontal and you're currently on vertical, here's the link. If you're on TikTok and you want to watch it horizontally, then you have to go to the link tree in my bio, click on the Dr. Blitz Debunks YouTube channel, and then you can watch it there. All right. Somebody said he will never answer this question. Bet. Let me just find the question. Oh, he didn't actually, like, I don't actually see a question from him. So you're right, I won't answer your non-question. Could we create a telescope that could use the sun as some kind of gravitational lensing machine? Yes, this is actually something that's been proposed. There's the gravitational focal point of the sun is something, I think it's out past Pluto, but it's not so far past Pluto that we couldn't send something there. And then you could use the sun as a gravitational lens. That's absolutely a thing that's been proposed. And it's really, really cool. Now we have a super chat from C-Bar. I saw Blitz at the bodega this morning. I asked him for a selfie and told me to get lost. I kid, I joke. This is slander. This is lies. What do you think about Boltzmann brain hypothesis? I think that any theory that expects Boltzmann brains to exist, you should throw away that theory. And I got this idea from Sean Carroll. Sean Carroll calls these theories cognitively unstable. And the reason why they're called cognitively unstable is because if you have some piece of evidence that leads you to conclude that that you are more likely to be a Boltzmann brain, like overwhelmingly more likely to be a Boltzmann brain, then that means that you shouldn't trust the evidence that you collected that led you to that conclusion. Because if you're a Boltzmann brain, then the evidence is not real, right? And so there's no evidence that should lead you to a theory that should lead you to conclude that you are a Boltzmann brain, right? Now we have Displaced Gamer again. Thank you so much with the $2. At initial expansion was movement faster than light. So look, expansion is not movement. Expansion is expansion. It's like stretching a rubber band. The rubber band isn't moving, it's just stretching. Now what you could say is that the distance between 2 points was growing faster than the speed of light. And yes, if the universe is infinitely large, then there will be 2 sets of points that where the distance would be growing faster than the speed of light. And you can calculate how far that distance must have been given a rate of expansion. But it's not a speed. You have to keep that in mind. From Mindforged Manacles with the $5, where does physics go if singularities and black holes are real? Oh, well, then we start developing mathematics to study singularities, right? And from Who is the JC with the $10, thank you so much. When solving projectile problems with air resistance, how do you solve the differential equation to construct the kinematic equations? Oh, then it's tricky. Then your differential equation is now a second order nonlinear differential equation, and the standard techniques to solve this differential equations just don't work. I mean, if you take a differential equations class, you will learn to solve it, but it's tricky. It's not trivial at all. Wait, how's the rubber not moving? Well, look, I mean, like the rubber band is not. It's not like points are like moving through space. It's like the whole thing is stretching. From Baron Kane, just send in $5 with the support. Thank you so much. From Grimlock with the $10, could you explain how black hole evaporation works? Yeah, so I have a video on this. From a few months ago, and I thought it was a pretty good explainer. Essentially, there's kind of 2 ways to think about it. If you think that virtual particles are real, right, then you can just imagine that virtual particles pop into existence at the event horizon. The virtual particle that's in the event horizon has negative energy, or that's inside the event horizon has negative energy. The particle that's outside the event horizon has positive energy, and so the negative energy decreases the mass of the black hole when it falls in. The positive one escapes. Fine. However, a view that doesn't require virtual particles is merely that quantum tunneling can escape the event horizon. And the rate of quantum tunneling for any of these fields is dependent on the mass and roughly the size of the event horizon. So that is a way to understand black hole evaporation. From Baron Kane, again with the $10, thank you so much. More astrophysics maybe, but if we have antimatter, positrons, flipped quarks, etc., could we have dark antimatter? It doesn't interact electromagnetically, but the theory is there. Yes, you absolutely can have dark antimatter. If dark matter is real, then and its particles, then it will absolutely have antimatter components. That's just how particles work. Does the vertical chat know that we can see all your comments in the horizontal chat? They probably don't. Yeah, so if you're on TikTok or on your vertical on YouTube, horizontal can see all of the comments. Vertical cannot see horizontal comments though. So, horizontal is a big W, right? Somebody asked, tell us some practical inventions you have created. Yeah, so when I was in college, I was like 19 or 20 or something like this. I designed a novel circuit for regulating lasers, regulating high power, laser diodes. And I ended up selling that circuit design for $3,500. So yeah, that's something I did. But aren't virtual C-bar with the $5 says, but aren't virtual particles placeholders for real phenomena? They're not placeholders, they're mathematical constructs, at least if you're a reasonable person, but they can also be useful for developing intuition. From Angela Garuso with the $10 again, can you explain the big bounce theory and what your thoughts on its probability of being accurate are? So I can't talk about its probability of being accurate because we just don't have enough data at this point. But the idea behind the big bounce is that if dark energy gets sufficiently weak and the shape of our universe is sufficiently curved, if you will, then the universe will recollapse in on itself. Now, the question is, what happens after it recollapses? Maybe it just ends at a singularity and the universe is over. But more reasonably, if you take some theory of quantum gravity to be true, like string theory or loop quantum gravity or something like this, there is some kind of hard core that you can't get denser than, and so it'll bounce off of that core, and then it'll re-expand again. And that's the idea of the big bounce. Now, the question is will it be identical to the way that it was? And that really depends on the dynamics of the recollapse. And from Sol Invictus, just send in $5 just to be a good lad. All right. How can general relativity be unified into a single coherent theory of quantum gravity? Great question. If I knew the answer, I would do it rather than tell you. Put wormhole at sea level and the bottom of Mariana Trench use pressure for hydroperpetual motion. Yeah, if you have wormholes, then you can get perpetual motion, yeah. Vertical chat is a pain in the butt. May very well be. Shots fired at non-nominalist, i.e. virtual particles comment. Yeah, well, yeah. Well, look, so the thing is anything that can be explained via virtual particles can be equally well explained without virtual particles. You don't need virtual particles to explain anything. They don't add any explanatory power. Why would you think that they exist? We know that they were constructed mathematically. It's not like they were predicted and then we came up with better ways to explain things. It's just we know what they are. We know exactly what virtual particles are. They are internal legs in a Feynman diagram. They are mathematical constructs. Feynman diagrams don't represent real processes. Feynman diagrams are a Taylor series expansion, right? Is there an alternate universe? Is there any reason to think they're accessible to us? Oh, if there is an alternate universe, is there any reason to think that they're accessible to us? No. Even if there are alternate universes, kind of by definition, they would not be accessible. Are you a physicist or an astrophysicist? I'm a physicist. I did not get my degree in astrophysics. Thoughts on Einstein's geometric unity? It's top tier crank. It's top tier crank stuff. So a crank is what people in physics call people who produce like gibberish. We call them a crank, and the stuff that Einstein produced is essentially gibberish. Given temperature is vibration in the atomic level, wouldn't protons be perpetual motion machines? So a perpetual motion machine is typically something that is expected to go on forever and not lose energy. But any sort of system that's jiggling around is losing energy. It radiates energy as long as it's charged. As the sole purpose of a heater is to heat the environment, then the efficiency of a heater should be 100% efficiency, as the energy loss is also in the form of heat, which will heat the environment. Yes, that's true. That's true. You can actually have greater than 100% efficiency for heaters by using a heat pump, which is interesting. But it's not really efficiency in that case. From Bree C with the $5, if Big Bang, Big Crunch, a cycle of creation and destruction is true, would the universe be in perpetual motion? Perhaps. But then we really have to rethink what thermodynamics is about, right? How would you use the Taylor expansion series in physics we're learning about in class? Yeah, so in fact, I just mentioned this. Virtual particles are merely the coefficients. Sorry, they're not the coefficients. Virtual particles are merely the variables in the Taylor series expansion for something that's very, very complicated involving quantum field theory. That's all a virtual particle is. It's just like you have 3 virtual particles if you have x cubed. You have 8 virtual particles if you have x to the 8th. That's all it is. That's really all it is. So yeah, Taylor series show up everywhere. It's the easiest way to approximate something. Tell us some practical inventions you have created. Really, you have no accomplishments. I already told you. I designed a circuit when I was like 19 to, control the current flow into a laser. Like I did, and it's still being used. Like the person I sold it to is still manufacturing them and still selling them. I don't know what else you want. Does a single atom radiate heat? If it's just moving at a constant velocity, no. However, if it's accelerating, then it will radiate electromagnetic energy. Okay. Was the Big Crunch ever proven? Nope. It is currently a hypothesis. Currently just a hypothesis. But it's like a live hypothesis. Like we can't dismiss it right out. Since the Planck time is the smallest possible interval of time, then wouldn't 10 minutes imply a finite number of possible moments in 10 minutes? The Planck time is not the smallest possible interval of time. That's a mistake that gets propagated a lot, but it's a mistake. It's not that. From Angelo Garuso, again with the $5, just for fun, what do you think is the most probable engine concept that could propel a ship to relativistic speeds? Oh, a nuclear engine. Either that or a light sail. Do you believe intelligent life exists outside of Earth? I know it's not a physicist question. Yeah, probably. The universe is really, really big. Please explain how heat works. These people don't understand clearly. Heat is just the flow of thermal energy from point A to point B. That's all it is. Angela, that was my last super chat for the day. Fair enough. Fair enough. Can you explain the recent experiment that proved the Terrell-Penrose effect? I haven't heard about this, so maybe if you can tag me in a video, I can check it out. Do you think we are close to a form of immortality? No, I don't think so. NASA proved the existence of God. Calculations kept coming up 10 degrees off. Only thing they come up with is when God turned back time. What are you talking about? What? I love people's regurgitated knowledge, but nothing I heard here was of personal substance. Well, I mean, I could talk about like my own research, like the stuff about DESI came from me, but like the stuff of the possibility of a cyclic universe from the DESI model, like that's original. And you know, I ended up writing a paper on it. From Displaced Gamer with the $10. Theoretically, can we create technology to add an atmosphere to the moon? We expand on the moon, moon gains more mass, hits Earth. In the reverse, we mine the moon, moon fly away. Just a fun question. Yeah, so you would have to make, okay, so we're talking about changing the mass of the moon. So you'd have to make the mass really, really heavy. Actually, no, you know what? There's no amount of mass you could take from Earth and put on the moon that would cause the moon to collide with the Earth. And the reason I say that is because the center of mass, all that'll do is it'll shift the center of mass away from the Earth towards the moon. But both of them will still orbit the center of mass, and the orbits won't necessarily get tighter, right? And Grimlock sends $5. Between the horizon and the singularity, is there possibly vast area, or do you likely just run into the singularity immediately after the horizon? Yeah, you can just compute the area. I mean, area is hard to define inside there, but you can compute the amount of time it takes to go from the event horizon to the singularity in like a Schwarzschild black hole, and it's just like a finite amount of time. For a supermassive black hole, I think I did this calculation a while ago. I think it was for Sagittarius A star, the one at the center of the Milky Way. It would take about half an hour from falling into the singularity, like starting like just outside the singularity at rest, and then just letting go, just like, so you're hovering there and then you turn off your engines. It would like take half an hour to hit the singularity. Hey Blitz, always enjoy your streams. Well, thank you. The dark matter that surrounds us, how much do we know about it related to our basis for life? So dark matter, if it exists, would have no effect on life whatsoever. What's the term for the smallest space between 2 points? We don't know if there's one. We don't know if our universe is continuous or discrete. We just don't know. Sorry, the question I had was, how do you modify the Bragg peak of a proton beam without changing its energy delivered? That's a good question. Well, okay, so if you don't want to, I don't know if you can, right? I mean, like the Bragg peak is determined by the energy. So for those who don't know, the Bragg peak is if you plot the amount of energy lost for a particle traveling through some material, there will be a peak distance that it'll travel through a certain amount of distance, and then it'll dump most of its energy within a certain range, and then it'll basically stop. So the Bragg peak, and this is super useful for medical radiology, or for in medical physics for doing radiation therapy, because you can just it's a very small region, so you can shoot protons, high energy protons into somebody's brain, for example, and most of the energy will be deposited where you want it to be at the Bragg peak. And so you can use that to kill tumors without killing the surrounding tissue. But being able to control where that Bragg peak is hard. Now, the thing I would think that you would do is you would just put more material in front to move it back. I don't know how you would move it forward without changing the energy, though. Grimlock, also, have you hydrated? I have not. Thank you for the reminder. Somebody asked, is Blitz your real name, or are you just joking? That is a secret that I will not disclose. Why the Feynman diagram in the background? Well, because that's quantum field theory. And then there's the curved spacetime in the background, the black hole thing, for gravity. Those are the kind of the two pillars of fundamental physics. Right. Theme song is cool though. Yeah, somebody made it for me. It was really cool. Why does general relativity fail to describe physics at the singularity of a black hole or at the moment of the Big Bang? Yeah, so the issue is that general relativity predicts a singularity, and we expect that singularities are not physical, because that would imply that there's like an infinity that you can measure, which probably doesn't exist. So we kind of say that, oh, well, general relativity breaks down there because it gives the wrong prediction. What determines which direction a black hole rotates in? This is a really good question. It's fairly straightforward. It's just whatever formed the black hole, whatever direction it was rotating in, that's the direction that the black hole rotates in. Also, I'm getting spammed by like spam text messages, and I just need to check this out, make sure that everything's okay. Oh my god. Blah, 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 complete blah, blah. Oh, okay. Sorry. Was the movie Interstellar realistic with its time dilation stuff? Yes, it was. Although it's not realistic that you could have a planet that close to a black hole. That's not the realistic part. When matter is lost to energy conversion, is there a way to recover it in the form of matter, or is it permanently lost to us? Yeah, we can make new matter. In fact, if you collide two protons at high enough energy, then you can produce stuff that has more total mass, more particles with more total mass than the original two protons had. From Angelo Gerusa with one more. I thought that one was your last one with the $5. One more. Have you ever thought about collaborating with Kyrgyzstan for a video? If they wanted to collaborate with me, that'd be awesome, but they're huge. From PM with the 5 Canuck bucks, photons experience leaving a star hitting my eyes in the same instant. Could this be used as an argument for determinism against causality? Photons don't experience anything. There is no valid inertial reference frame for a photon. So to ask, like in the same way that we would say like, oh, we experience this amount of time, we experience that amount of time, what we're talking about is the proper time in our reference frame. Photons don't have a reference frame, so that doesn't even make sense to talk about experiencing anything, let alone anything about the same instant. Now, photons do travel, you can measure the time a photon experiences, if you will, big air quotes, using something called affine time. So you can definitely talk about before and after, even along a photon's trajectory. There's no issues there. I think that this is actually genuinely just a confusion that people have spread for the longest time, that photons don't experience time. Photons don't experience proper time, but there is a way that you can make sense of the time that a photon experiences, big air quotes again, using affine time. Affine time just doesn't have lengths of time associated with it. It only has befores and afters. By the way, we're currently trying to monetize the horizontal stream. And what this means is that we need more people's eyes on the horizontal stream videos. So whether you're watching the stream or you're watching the videos, I need like 3,000 or 4,000 public watch hours on the horizontal stream. And so what that means is that y'all should go there and subscribe and watch the videos. The live stream, or that YouTube channel where the horizontal stream is, I post all of the clips to all of the debate clips there. So if you want to see a given debate rather than having to watch through an entire debate, go watch it there. And, you know, I try to keep the good ones only. So make sure to go do that. Make sure to subscribe as well and all of these lovely things. Now, this is strange. I don't understand why this was message retracted. But Gen Z Bible Story sent $1. So thank you. Is dark matter a placeholder for the empty space? If so, what does it do and how? No, dark matter is not a placeholder for empty space. It's a placeholder for something that seems to have mass that we can't see. That's what it is. From Philip Kelly with the $5, can the spin of a black hole cause friction, like touching a spinning ball causes friction that slows the ball? Sort of, yes. So there's something called the lens-Thirring effect. And so if you are... So there's kind of two things. So there's the lens-Thirring effect, and then there's frame dragging. These are closely related. So if you have something that's orbiting a spinning black hole, you can do that in principle. Or spinning anything, really, because everything causes this to happen. Anything with mass that's spinning causes this to happen. Then you can actually notice that if you have like a gyroscope, that gyroscope's axis will change. It'll start out maybe in one direction, and then it'll change as it'll slowly start to change as it goes around because of the rotation of space-time. Also, if you start falling towards a spinning black hole, you will start to fall around it. You won't orbit it, but your trajectory will curve with it, will curve with the spin. This is called frame dragging. Now, we have $10 from High End. Thank you so much. Is there a black hole large enough where you don't get spaghettified falling in? Also, if a singularity is a moment in time, end of time, does that mean that you can watch the death of the universe / black hole? Great questions. So there's two of them there. So there are plenty of black holes large enough where you don't get spaghettified falling in, at least crossing the event horizon. Every supermassive black hole will be a black hole that's big enough where you will be fine if you fall in. Now, you will get spaghettified eventually as you get closer and closer, as you fall deeper and deeper, but as far as anyone on the outside is concerned, you never got spaghettified. Now, as far as the singularity being a moment of time, it's kind of like the end of time, that's only true for non-rotating black holes. For rotating black holes, the singularity is not a moment in time, it's more of a place. And so the question doesn't really work. However, for non-rotating black holes, you still can't see the end of the universe, the death of the universe in a non-rotating black hole. It's not the future infinity of the universe, it's just some finite time, and there's things that you would not be able to see, things that would happen in the future that you would never see. All right, we detected inactivity. No, you didn't. I'm here. Did you watch Interstellar? And if you did, was it enjoyable for you? Yeah, I did. I liked the movie. I thought it was really good. Can you explain the double slit experiment? I have several videos on it, but essentially the idea is just that if you have, in principle, the information available to detect which slit the particle goes through, then that means that you've done something to that particle to make that information available, so you will change its behavior, and it will only behave as if it's traveling through one or the other slit. What do you say to the genius arguing 1 × 1 = 2? That he's not a genius, and that Terrence Howard should probably just stop talking. Is there a hypothetical way to create / destroy matter or energy, or is it impossible based on current information? Yes, matter destruction is totally normal. Matter creation is also totally normal. When you have a banana in your kitchen, bananas have potassium, a type of radioactive potassium in them. And that potassium sometimes decays by producing antimatter. Now, that antimatter then goes and finds its matter complement somewhere in your kitchen, and then it annihilates, and both the matter and the antimatter cease to exist. The matter is gone. It annihilates, it just becomes light, or gamma rays rather. Now, destroying energy is a little bit trickier, but if you shine a laser beam into space, so long as the universe is expanding, that laser beam will be losing energy as it's traveling through, because the light waves will be stretched out, and light waves that are stretched out have less energy. So yeah, absolutely, these are both things that we understand. Did any of the students you found cheating ever contact you afterwards? Yes, one of them did, and they actually thanked me. They said, yeah, thanks for that, because they ended up just getting a letter grade doc, so they went from like a B to a C or something like this. So they said, thanks for catching me and for being strict and for, you know, being merciful, if you will, because it got them in line. And then they graduated, and they graduated with a pretty good GPA. So doing that kind of thing, especially for first years, is like a really good wake-up call, because then you can get onto the right track for the rest of your degree, and you know, it can definitely be helpful. Double slit is crazy, and you should Google it, and you may not understand it. I absolutely do understand the double slit. I can assure you that. My super chat didn't go through, but my bank did say it did. Oh, that's weird. Andrew, let me double check. Well, why not just send your question and I'll highlight it anyway. Yeah, Andrew, just send the question. I'll just highlight it anyway. Are you familiar with change ringing or method ringing, church bells, where ringers commit to memory rules for each change? No, I've never heard of this. Can you help me understand the uncertainty principle in quantum physics? Yeah, so the uncertainty principle, it's actually not so weird. So the uncertainty principle is merely the statement that particles are waves, like everything is waves, and waves, you can't tell where a wave is and how long the wavelength is at the same time. That's all the uncertainty principle is. So if you have a wave that's just like one bump, like that, then you can know where it is, but you don't have enough bumps to measure the distance between them to figure out the gap between the wavelengths, or to figure out the distance between the wavelengths. On the other hand, if you have a whole bunch of waves, a whole bunch of peaks, you can figure out the gap between them fairly accurately, but you won't be able to know where it is because it's spread out. So that's all the uncertainty principle is. Okay, so I'm going to highlight Andrew's question. Although I know we don't see, so Andrew did send a super chat, it just didn't go through. So although I know we don't see any evidence of this, what evidence would we see if there were just an atom of, if we were just an atom of a bigger universe? I guess you would see, well, we're not an atom, right? I don't know what you mean by an atom. If you mean like that we're just like a small thing in a bigger, like we could be a small thing in a bigger universe. This is one of the ideas of inflation, something called eternal inflation, but we're not like an atom. An atom implies certain structures, right? That there's a nucleus and then that there's like a diffuse charge cloud around it, but we're just not that. So I'm not really sure Like we know that we're not an atom in a bigger universe. Now we might be like a small patch of universe in a much larger universe. That might be the case. And the evidence of that would be akin to evidence of inflation, but that's not really the same thing as us being an atom. You doing guest request questions? No, I'm not. I just, like, there's so many questions now because now we regularly get like 600 people. I just don't, like, if I want to get to questions, I just can't do the guest requests anymore. From Squeaky Eyes with the $5, we demonstrate space-time bending on a flat sheet, but wouldn't it make more sense to show pinching inwards evenly around Earth from all positions? Yeah, there's actually a really good picture. Look up space-time curvature. There will be a nice three-dimensional view that shows exactly that. Oh, I wasn't saying you blitz about double slit. Ah, fair. Q, will you hit the sun that's turned into a black hole? If the sun turned into a black hole right now, we would not fall in. Have you heard of Joao Mag... I'm not going to try it. No, I haven't heard of him. Is the uncertainty principle a limitation of instruments technology or a limitation of the universe? It's a limitation of the universe. Like I said, it's just about the fact that you can't know where a wave is localized to and how long the wavelength is with the same degree of accuracy at the same time, or with high degree of accuracy at the same time. That's all. Why are 2/3 of galaxies spinning in one direction, not 50-50? That is a good question. So far as we can tell, there's only one paper that makes that claim, and it needs to be supported. But if it is true, then that is really, really cool and should make us think about what's going on. Like, why is this the case? Now, I think that almost certainly it has nothing to do with us being in a black hole. I think that if you assume general relativity is true, then you can't have us being in a black hole, or rather, us being in a rotating black hole wouldn't imply that, for reasons that I could go into, but I'm not going to. All right, let me hydrate some. Are we closer to the Planck length or the entire universe? Didn't somebody make a video about this recently? I don't remember. So the Planck length is 10 to the minus 35 meters. A light year is 10 to the 12 meters or something like this. Sorry, it's like 10 to the 16th meters. And then our universe is like, our observable universe is like 100 billion light years across. So that's what, 10 to the 11. So 10 to the 11 times 10 to the 16 is 10 to the 27. The Planck length is 10 to the minus 35. So we are 8 orders of magnitude closer to the size of the observable universe than we are to the size of the Planck length. So yeah, how was that for some fast maths? What is Avi Loeb trying to achieve with the conspiracies? Look, I can only speculate. This is just my opinion, but he's written a few books, and I suspect that putting more out into the media that gets his face out there, he sells more books. That's what I suspect. Fears Interaction sends $2 with, is $2 enough to stop scaring me with banana facts? No, bananas are real. Bananas emit antimatter, but it's like a negligent, like it's one atom. It's one antimatter electron every 40 minutes or so. So you're fine. Can you explain the 1935 experiment with a cat? There was no experiment with a cat. Schrodinger's cat was not a real experiment. It was a thought experiment. It was an idea that someone had as a way to kind of try to show that the Copenhagen interpretation, which is the popular interpretation of quantum mechanics, doesn't make any sense. How is it that they've been studying black holes for decades and only recently seen one? Well, look, we've detected black holes going as far back as the 70s, if I remember correctly. However, imaging a black hole, because they're black, they don't emit light, is very challenging. And so it takes a lot of technological advancements and physics advancements to actually do that. So of course it was going to take a while. But the theory is really sound. From Dan B, we have $10. Heard another physicist on TikTok saying we are energy bodies, considering the empty space in atoms and how we only touch anything via our electron charges. Any thoughts? I'd love to know who this physicist is. It sounds like that they're probably not... Well, maybe they're not a nominalist. Maybe they're a bundle theorist or something like this. I suspect that they just haven't thought about metaphysics all that much, and they kind of just said it because it sounds cool. But look, there aren't empty spaces in atoms. At least if you take like the typical quantum mechanics seriously. Like atoms are filled with the atoms are filled with the electron clouds. Like the electrons are smeared out, filling the entire atom, right? And so they're not empty. And Yeah, I mean, yes, the way that we touched it was Neil. Okay, well then Neil says a lot of dumb has a lot of dumb metaphysics. Neil's a great science communicator, but he just has a lot of dumb metaphysics things. So we do touch things via the electromagnetic force, but that's what it means to touch things. I don't know what else touching would be. Can you explain why physicists keep putting cats in boxes? Well, we have to take them to the vet. You have to put a cat in a box to take him to the vet. Why is there something rather than nothing? Why could there be nothing? So the cat didn't die for nothing. There was no cat. The experiment never happened. No cats were harmed. Do you think that they could make heavy elements stable if they use protons instead of positrons? They don't use positrons. They use protons and neutrons to make heavy elements. What's up with AI and biotech? I don't know. Not my fields. Is negative mass and energy possible? They're like hypothetical, like naively the math works out, but we don't have any reason to think that they can actually exist physically. Question, if supermassive bodies like black holes and hypergiants dilate time, does that mean that they're older than, let's say, a distant object that orbits it, or from observations at a distance? Yeah, so when we talk about how old something is, we're typically talking about its own proper time. So a thing's proper time is always the fastest. Everything else always views it as slower. But like generally, when we're talking about like some object in space, if we say that that black hole is 1 billion years old, what we mean is that 1 billion of our years have passed since the star went supernova and caused the black hole. Like that's just what we mean. Do you think general relativity could be expressed by applying quantum mechanics at macroscopic levels? I don't think that you'd get general relativity out of quantum mechanics, but you would probably start running into some weird stuff, yeah. What gives or defines the orbital shapes within an atom? Essentially, it's angular momentum conservation. It's the fact that electrons are waves, and the fact that electrons are waves means that they can only exist in patterns that are like self-constructively interfering rather than destructively interfering. It's very similar to the way that you can only have certain kind of wave patterns on a guitar string. You can't have a wave pattern like if you pluck a guitar string that's fixed on both ends, it'll only oscillate in certain kinds of ways, right? What's your favorite end of the universe hypothesis? Heat, death, vacuum decay, ekperiodic, or other? I prefer some sort of cyclic model, but that's merely a philosophical preference. There's not like some evidence supporting that. 3i Atlas, your thoughts? It's a comet. I made 3 videos on this in my debunking playlist on TikTok, so go watch them. A random physicist? I'm good. Okay, you don't have to watch. You can leave. Where did everything come from? Maybe it's always been here. Could the universe be a 2D hologram because of how information is encoded on the event horizon of a black hole and how the surface area is proportional to its circumference and not its volume? You mean the entropy is proportional to its surface area rather than its being proportional to its volume? The area of a black hole, the surface area of a black hole is absolutely proportional to its, neither thing is related to the circumference, but yes, so this is the holographic principle. The thing about the holographic principle, I think it's really pointing at something that we don't understand about what entropy is and what black holes and gravity is doing. I don't think that we're actually a 2D hologram. Rather, the holographic principle is merely saying that there is some other mathematical description that we could also give. In relativity and magnetic force in relation to charge density, is there multiple I don't know what that question means. Dr. Blitz, is there anything you want to brag about right now? No. So the universe is eternal? I think so. I think it could be, at least. If dark hair is accelerating the expansion of space, how could Hawking's big crunch theory still be possible? The accelerated expansion of the universe is decreasing, and this is a recent observation. Does time pass even slower due to special relativity on Venus and its proximity to our sun, even though its day is longer than its year? So the length of the day, the length of the year, these are completely unrelated. What we're talking about is how long, if you had an atomic clock on Venus and you had an atomic clock on Earth, which one would tick faster? Now there's kind of a few things happening here. It is closer to the sun, so absolutely it would have a different rate of, it would have different gravitational time dilation. Its orbit is also a different speed, so it would have some extra special relativistic time dilation. Also, Venus is a smaller planet, so it would have its own gravitational time dilation. So the calculation would be a bit involved. It's in principle doable, but it'd be hard to say. Because the primary things would be the relationship between its orbital speed around the sun and its distance from the sun. That I would have to actually work out the calculations for. I suspect that it would be slightly slower, in the same way that GPS runs slightly slower. because it's orbiting the Earth, but it's hard to say. Is it possible a black hole isn't a singularity, but just a large object with tremendous gravity? Yes, but it has to be smaller than the event horizon. Otherwise, if it's not, then we would be able to see it. What are your thoughts on loop quantum gravity? I read a review on it like a year and a half ago, like a very, very long review. And it was really compelling. The review was really, really compelling. Now, there's still a lot of issues with it, but the idea, I think the idea is good. I think that it's grasping at something true. Now, whether or not the actual theory is correct, or whether or not just some of the ideas are correct, that's a different story. What is the largest size an object can be that will follow quantum mechanics and not classical? Well, so the Nobel Prize in Physics of 2025 was awarded for producing a large, what you might call even a macroscopic quantum atom, like artificial atom. This is something that we saw quantum properties of the thing, even though it was slightly smaller than the width of a human hair, which is definitely something that you can hold. It's not like just a single atom or something. So we don't actually know what the upper limit is. We just know it gets harder and harder to make them quantum. It's harder and harder to make them behave like quantum things as they get bigger and bigger. If gravity makes gravity, does everything make gravity? Because gravity itself should have no weight. So gravity gravitates. That's absolutely true. Insofar as the field equations are nonlinear. And what that means roughly is if you think of gravity as being as causing a potential energy, well, gravity is sourced by energy. So if gravity causes potential energy, then that potential energy will cause more gravity, smaller in magnitude. So like it doesn't like go on forever. Like you'll have some potential energy caused by mass, and then that potential energy has a little bit of mass equivalent, and so it will cause a little bit. The gravity that causes is actually negative, so its own self-gravity will be a little bit less than it would have been if it was just the gravity from the mass, and then that negative self-gravity contributes positively to self-gravity. But the point is yes, gravity gravitates, and so gravity can, in some sense, contribute to mass, if you will, and that's roughly what a black hole is. A black hole doesn't necessarily have anything at the center; there's just gravity there. Nobel Peace Prize has lost all credibility? Maybe. Is space and time something real or just an abstract concept? That's a good question. Does that mean that the force accelerating the expansion is throttling back? Yes, roughly. Why do we have the right-hand rule for magnetic fields? Can it be left-hand? How is it not symmetrical? You can use the left-hand rule, then you just need some minus signs in some places. How much of physics research these days is sitting in front of a computer doing maths and simulations versus in an actual lab? So theorists and computational physicists will be sitting in front of a computer or sitting in front of a blackboard. Experimentalists will be doing an experiment. Now, a lot of the particle physics experiments, you work in front of a computer because you can't fit the particle accelerator on a desk, right? Particle accelerators are huge now. So you control the particle accelerator from the computer. And then you collect data, maybe you build your detector on your desk or whatever. The point is experimentalists still genuinely do experiments in actual labs. It's just sometimes those labs are virtual in that you're controlling the actual lab from your office. Does Dr. Blitz remember me? Gen Z Bible stories. I absolutely do. Is it possible that the universe would collapse back into itself for starting the Big Bang? It's at least conceptually possible, and I think that we can't rule that out yet. You said in your recent short, QED is one of the most successful theories. Is it just the accuracy of math? What would be the second most successful theory in science, in your opinion? So it's the most successful because the predictions of QED, the math of the theory, match up with the experiment to such a high degree of precision, right? Within 1 part in a trillion or so. Now, for certain calculations. Now, the second most successful theory, I don't know, that's probably the electroweak theory or something like this. That's probably it, because things like decay rates and we can talk about really, really accurately. I'd have to look into it though. But nothing's going to come even close to QED. How is there a Big Bang if energy cannot be created? Where did the energy come from? Well, first of all, energy conservation is only true approximately. It's not true on a cosmological scale. So this is not really an issue. But even if it were true, all that would imply is that it came from somewhere else, that there was something beforehand. GR and SR are super precise. That's true. Yeah, so I guess we could say that the expected decay rates from special relativity, like if you take a muon and you collect its, the predicted decay rates from special relativity for, okay, let me back off, sorry. If you have a muon, muons are particles, they decay into electrons and antineutrinos. They have a certain decay rate. Typically, they last 2.2 microseconds or something like this. However, for the traveling very, very quickly, relative to you, it will take them longer to decay because of special relativity and time dilation. Now, if it's the case that you can predict what that decay rate is very, very accurately with special relativity, then you would have another good theory. Now, the question is, I just don't know what the error bounds are on these calculations. So, any thoughts regarding Penrose philosophy and its connection to physics? Oh, process philosophy. I don't know anything about process philosophy. Will the idea of entropy increasing over time imply minimal entropy at t equals 0? In some sense, yeah. Or it would imply that time flows in the direction of increasing entropy. And so if you have decreasing entropy, that just means time flows in the other direction. Do you have any advice for someone who would like to learn physics but can't afford classic education? I would like to be a science person like you, but I have a cue ball for a brain. Well, look, so you could in principle self-teach. It's just always going to be so much harder. It's like, there's a reason why universities work to an extent, and it's because you have access to the people who are experts. And if you don't have access to those people to answer your questions, then you'll have a hard time. Can you give some information about the DESI finding about dark energy evolving over time? Yeah, look up DESI, I think it's called like DESI data release. I have it right here. Is it DESI 2? It keeps popping up, but then it goes away. DESI DR results 2, measurements of baryon acoustic oscillations and cosmological constraints. That's what you should search, and you'll find the paper. Have you gotten more or less patient with flirts over your time doing this? It depends. Yeah, so that's the name of the paper, if you want to read about it. Is it possible that we have overlapping dimensions? It's like conceptually possible. It's not like a thing in physics. Oh, my nose isn't. Okay, good. My nose isn't bleeding. I had a nosebleed this morning. That's why I was late, because I had to deal with that. Can you recommend any beginner quantum or astrophysics books? Yes, this is sort of an astrophysics book. It's a cosmology book. Read A Brief History of Time by Stephen Hawking. It's a very, very good book. Take a screenshot. It's a bit outdated, but it's excellent. Will AI solve current physics unknowns? Can I solve everything? Time crystals? I suspect probably won't. Are you still in the Czech Republic? No. Have we successfully used dark energy matter in a helpful way? No. I mean, unless by helpful you mean like understanding the world, then yes. Did the early universe produce equal parts matter and antimatter? We don't know. Probably, it seems like not, because if it did, then we would see it. Do you think you could do a physics PhD after aerospace engineering undergrad, specifically material physics? Perhaps. I mean, like, you have some catching up to do, but perhaps, yeah. What's your opinion on the many worlds interpretation of quantum mechanics? I think it's the right one. I lean that way. How did supermassive black holes form? Well, the current idea is that they formed via direct collapse, perhaps with a dark matter seed. In the very, very early universe, you have direct collapse rather than passing through a star and then accreting matter. Is there a correlation between entropy and the development of star systems and planets? Yeah, so when a star forms, the entropy of the system goes up. Gravitational collapse causes entropy to go up. So, yeah. Why are you not answering, bro? I am answering. Do you think dark matter is real, or our theory of gravity needs to be changed? I think dark matter is probably real. In the many worlds theory, is there a flat earth world? No. In the many worlds interpretation of quantum mechanics, the laws of physics are still true. Do you think time is emergent or fundamental? I'm agnostic about it. So if everything in space other than stars is dark matter, do we understand dark matter? Well, it's not everything. There's like dust and other stuff too, but like, no, we don't fully understand dark matter. No. Has anyone tried to throw Jason Lyle's ASC variable light speed nonsense in a debate? He has. I think I've spoken with someone a long, long time ago who did. But I don't remember how it went. I mean, like, she was just like a creationist type again and just saying, oh, but you can't prove. And so I'm like, okay, well, sure, I guess. What is the many worlds theory? It's the many worlds interpretation of quantum mechanics. And it's basically just that rather than making a measurement causing a quantum superposition to collapse to one of its possible states at random, it's that when you make a measurement, the world basically splits so that all outcomes are equally realizable, or equally realized, rather. Did CERN make black holes and ruin my former dimension in 2009? No, CERN never made black holes. Does time have an entropy equivalent? I don't know what that question means. Do you think there are any problems with undergrad physics education? Oh, I'm sure that there are, but as far as I don't know if there's any better ways that we know how to do it right now. And to be fair, I haven't been an undergrad in 10 years, so maybe there are problems now. How scared are you of America slipping into intellectual dark age? Me, myself, I think we're halfway. Oh, I'm very worried. Is the sky actually majority violet due to Rayleigh scattering, but we perceive the blue more? Well, kind of, we do perceive blue more than violet, but it's also that the sun's spectrum peaks in the green, and so there's just not a lot of violet. So even though violet Rayleigh scatters more, there's less violet to begin with. Why does water have surface tension? So surface tension is just what happens when you have molecules that are attracted to each other, and water molecules are attracted to each other. That's it. Like they want to stay touching, they want to stay close to each other. And so if you didn't have surface, so surface tension is just the attraction resisting them spreading out, right? Because if they were spreading out, the distances would get bigger. Can you give some information about the oh, I already answered that. Are you a reductionist, or do you believe in strong emergence? I don't know the distinction between strong and weak emergence. I'm a reductionist in some sense, but I think that emergence is like a genuine thing. Like they're non-computational emergent phenomena, or non-computable emergent phenomena. How could the Higgs tunnel into a more stable state? Well, look, if you have a quantum system and it's in an energy minimum, but there's a lower energy minimum that's nearby in state space or in configuration space, then it could in principle tunnel there, right? There's a non-zero probability of that happening. What do you think about Professor Dave? Is he a good science communicator? I don't watch a lot of his stuff. I know that he's like his debates are like really blood sportsy, but I don't watch a lot of his stuff. He seems like a good dude though. Like I've talked with him before. I just haven't watched his stuff. Also, at one point, he reached out to me and asked if I would write him a script for a GR video, and yeah, I just don't have time to do that. Did the matter of the universe come from a field that collapsed? What's the field? So the way that we describe matter these days is as excitations of quantum fields. Make of that what you will. Isn't God just physics with extra steps? I don't think so. How do photons convey the changing sign of the field produced by a sinusoidal EM wave? Well, photons are waves, right? Photons are waves. So they do that. Is one EM wave a single photon, or one electric and one magnetic photon paired together? Oh, yeah. So a photon is a combination of an a photon is is the smallest piece of the electromagnetic field that you can get. It's the smallest wave that you can produce. What's your favorite book about modern physics that doesn't go too deep into the math? I love physics, but I maxed out with math at Calculus 1. Something Deeply Hidden is very good. It's very, very good. If we invent material 100% reflective, will it be possible to capture light infinitely? Well, given what we know about quantum mechanics, it's impossible to do that. You won't answer my question. Okay, then ask it again. I don't see every question. You know how many questions I'm getting? I'm getting like 100 every minute. So chill out, bro. I'll scroll up and see if I can see it, but I'm not really seeing it anywhere. Somebody named Nick. Yeah, I don't see your question anywhere. Do you know about King Crocoduck, the PhD in physics YouTuber guy? I don't. I've never heard of him. Isn't that just a mirror? No, mirrors are not perfectly reflective. Right? Mirrors reflect like 96% of the light. Is it possible to control gravity? Yeah, I mean, just by like moving stuff around, right? Thoughts on black hole cosmology? Is it testable? Under GR, I think it's impossible, actually. And it's an idea that I have toying around in the back of my head. I'm going to probably write a paper on it eventually. I just haven't gotten around to it yet. How do we come up with the gravity formula? Well, we didn't. Newton did, right? At least Newton was the first to do it. I don't actually know like the history and the process that he went through to do it. I just don't know. I don't know the details of that. Are the solutions to general relativity just an Euler method approximations or Runge-Kutta approximations for the trajectory and the vector field? Would that make space-time the vector field? Well, I mean, there are exact solutions that don't require like the Euler method or the Runge-Kutta approximation. You can build an infinite dimensional vector space from space-time metrics, and then you can ask, what is the trajectory through space-time metrics that solve the Einstein field equations? You can do that, but like I think that's kind of avoiding what you're asking, or like not really what you're asking. Okay, did Nick ever ask another question or no? No, I don't see Nick's question. Oh, negative. So Nick did not ask another question. Okay. Do you ever use quaternions for your predictive models? No, I never worry about quaternions. So do you think gravastars could be a legit replacement for black holes? Gravastars are the ones where you have like the negative pressure pushing out, right? Let me just double check, because I always get gravastars and what's the other one? There's gravastars and then there's a third thing, or there's a second thing. God, I've made a video about both. Well, there's fuzzballs, there's gravastars, there's oh, it was like done in 2006. Anyway, gravastars are the one where where they have an outward pressure pushing outward. I think that these are like a decent idea, but like it requires physics that we don't know. So I don't think that they're where we should be. I don't think that we should be putting our money in that basket, right? What's the nature of, oh, okay, here's the question from Nick, I guess. Oh wait, where'd it go? Sorry, not trying to be annoying. I've sent it 100 times. Well, look, if it doesn't look like it's coming up, so maybe rephrase the question, because like, if it's not coming up, it's not coming up. I wanted to clarify my understanding. Oh, shoot. Okay, yeah. I want to clarify my understanding that the differential equations are making space-time fabric. I wouldn't say that the differential equations are making space-time fabric. Differential equations describe it. Dark stars, that's what they're called. Yeah, dark stars. Yep, that's the other kind. Oh no, it's not dark stars. That's a separate thing. But no. Can you explain your repost on the guy turning plastic into gas polluting his neighborhood? Yeah, that guy always just kind of like, okay, so we're talking about a guy, what's his name? Oh, I don't remember his name. But there's like a guy who he goes super viral for being like an inventor who's defying the oil and gas industry, and like his whole thing is like he's shooting microwaves at plastic. The plastic is then breaking down and giving off like super toxic gases, and then he collects some of them and turns it into gasoline. Like that's his whole thing. And this is called plastic pyrolysis, and it's been known about for a very, 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 very long time. In fact, it's already used in industry, and he's just doing it in a less safe, more polluting way. Now, something that he's doing that's nice is that the energy he's getting to heat up the plastic is coming from solar panels. But like, he's really going in on like the whole, oh, you know, the oil and gas industry don't want me to do this. No, there's a reason why they don't do it. It's because it's not efficient. It's not efficient, and it's super dangerous and super toxic, right? And he plays into this, and he's like, you know, he's like, oh, well, there are helicopters over me, so if I disappear, know that I love life, and I didn't want to end my life. Or like, he plays into this, and it just seems like it's a grift. Why is the star in star possible and not be just like a giant ring as it's spinning in one direction, so it should collapse at I don't understand that question. The plastic to gasoline guy did that, but there were a few people that got gas from plastic by removing chloride and getting back gas. What? Okay. If the universe was the surface of a 4D sphere, is that different from being in a 3 torus? Yes, those are different. They have different geometries. Yeah. What's your area of expertise in physics? I do relativity. So if it involves black holes, if it involves like the mathematical formalism of black holes, if it involves early universe cosmology, the mathematical formalism of early universe cosmology, those are the things that I'm knowledgeable about. Like these kind of mathematical formalism of these kinds of things. I don't do like computational stuff. I don't do data analysis. And then differential geometry, but that's more mathematics than anything. Wait, so let's say you put Earth's state in general relativity differential equation. There is a deterministic solution to where it will go, or does that have to be solved numerically? So are we talking about like Earth around the sun, or just Earth alone? Because yeah, so general relativity is deterministic, right? Now, the actual numerical solutions are really, really hard to solve because they're super nonlinear, but yeah, it is deterministic. And you do have to, yeah, so if you're doing, so the two-body problem doesn't have an analytic closed form solution, or doesn't have a closed form solution in terms of, you know, the fundamental functions in general relativity. So the two-body problem, just, you have to do it numerically in general relativity, but that doesn't mean that it doesn't have a deterministic solution, right? It just means that like the tools that we have just aren't sufficient. Are theorists working on finding similar connections like ADS-CFT duality? Theorists are still working on that, yeah. Is that the person melting plastic in a huge vacuum? It's not a new thing. Yeah, it is that guy. Is it true the universe had perfect conditions for life to exist? No. I mean, they had conditions admissible for life to exist, but I wouldn't say it's perfect. Can you explain Christoffel symbols? Yeah, so imagine they have two arrows in space. One's pointing this way, one's pointing this way. A Christoffel symbol basically just tells you what happens if you take this arrow and you drag it along this arrow following the curvature of spacetime. It tells you how much that second arrow changes. Dr. Blitz, who are some of your heroes in your field of study? Roger Penrose, Stephen Hawking, Albert Einstein, these types. Can you square believing in many worlds with Occam's razor? Yeah, it's a good question. So Occam's razor is, what are you assuming when you go into your, what are you assuming in your ontology? Not what is implied by your ontology, but what are you assuming in your ontology? So in the ontology, or in quantum mechanics, if you just assume that the Schrodinger equation applies to all systems, big and small, and then you just build in, like if you just make that one simple assumption that the Schrodinger equation applies to everything rather than just microscopic things, then you get a direct implication is that anything can be in a superposition. And what that means is that the many worlds interpretation is true. So the ontology, like it's actually, the many worlds interpretation is sort of the lowest ontology, or it's the nicest interpretation of quantum mechanics given Occam's razor. It has the fewest built-in assumptions, the fewest extra features, if you will. Now, if you add in that when you make a measurement, the wave function collapses to some observable state, you're adding in something extra. That's how you get the Copenhagen interpretation. But that's adding in something extra. So Occam's razor says, no, don't assume that. That's an extra piece of extra assumption. Anyway, can non-Euclidean geometry be used to describe warp space? Yeah, that's exactly what we do. That's what warp space is. Do you see any nearby implementations of the Nobel Prize proof of macroscopic quantum tunneling? Oh, all of the quantum computing stuff that builds on the stuff that the Nobel Prize did. It's already seen applications. Is teleportation possible via distortion of space-time via gravity? No. Does the existence of the Higgs boson mean the model of gravity is the curvature of space-time is wrong and must be replaced with a quantum field theory? No, not necessarily. Can you back off your mic just a bit? Move it away like 2 inches. Okay, I hope that's better. Sorry if I was peeking. Will we ever find any room temperature superconductor? I suspect so, yeah. What do you think happened to the Earth during the Great Unconformity? I don't know. That's geology, though. I don't know a lot about that. If you were sent to the MCU, would you be Hank Pym, Bruce Banner, another physicist, or a different hero? Oh, I mean, like, they're like, in universe, those are, like, the smartest people in the universe, so, like, I probably wouldn't be any of them, right? Would we ever be able to explain what a singularity is to the extent of human understanding? We know what singularities are. We have, like, a good mathematical description of them. They're places where space-time terminates, for example. Like, the mathematics is well understood. It just doesn't seem physical. So we toss them away. What are your thoughts on the creation of matter? What caused the Big Bang? Oh, I don't know what caused the Big Bang, but the Big Bang was not the creation of matter. At least that's not what the Big Bang theory is about. Please elaborate on your suspicion of room temperature superconductors. Well, I mean, look, like room temperature is not special. I don't know why it would be the case that there's no, that like there, it just seems kind of arbitrary, right? That like, oh, you could have superconductors up to, you know, negative 70 degrees Celsius, but you can't go higher than that. It just seems arbitrary. Now, like maybe that's just the case. But like, it just seems arbitrary. And like room temperature is really not that high of a temperature, all things considered. Yeah, and it depends on the room. That's a good point. What made you want to major in physics? Black holes were cool, so I wanted to study them. When was the creation of matter then? Well, I don't know if matter was ever created. The universe could have always existed with matter in it. Are there any theories, hypotheses on what could have created the Big Bang, or if the Big Bang was even created? So kind of the mainstream view is that the Big Bang came from something called inflation. Eternal inflation, if you will. And so this was just like a fundamental field, the inflaton field, that was in a very, very high energy state. And then as a result of quantum mechanics, basically tunneled down into a lower energy state and dumped its energy into the other quantum fields that then rapidly expanded, and that gave rise to our universe. That's the mainstream view. Kind of like it's not consensus, I would say, but it's probably the most popular. Shouldn't all Star Trek voyages be instantaneous for the crew? Why would they be? What do you think of the Nobel Physics Prize yesterday? Yeah, go watch my video on it. I posted one yesterday on it. Is it possible the Big Bang was created from the universe folding onto itself? I don't know how to interpret that question, so I don't think I can answer it. Big Bang was an explosion. What are you talking about? It wasn't an explosion. What do you do in your free time? I've been playing a lot of Overwatch lately, which I don't have a lot of free time, but in the free time I've been playing a lot of Overwatch. Does time stop in the black hole? No, not necessarily. Now, at the singularity of a non-rotating black hole, yes. But we don't think that there are non-rotating black holes, and also we don't think that there are singularities. How do you feel about the simulation theory? I don't think it's well supported by data. Dr. Blitz, what constitutes an observer in regards to wave function collapse? The Copenhagen interpretation doesn't say, which is one of the issues with the Copenhagen interpretation, right? Sonoluminescence, the explanation to the Big Bang. No, it's not. What are the mathematical principles behind the emergence of spacetime from quantum interactions? Yeah, so we only have like one example of this being the case, but if you assume, so there's something called the ADS-CFT correspondence. The ADS-CFT correspondence is the idea that in certain kinds of gravitating universes, not like our universe, but in a different kind of gravitating universe, it's conjectured that that various surface areas, like the size of a surface area, is related to the entropy of some quantum system that is holographic to it. And what you can actually show is that if you know the surface areas, if you know all of the surface areas of all of the surfaces, then you can completely which are exactly equal to the entropies in the quantum system, you can completely reconstruct all of the information about distances in the interior of the spacetime, the gravitating spacetime. And so the idea is roughly that entropy in the quantum system is or rather distance in the gravitating system is just a way of talking about entropy of a quantum system. That's all it is. That's the claim anyway. Now, whether that's true or not, this is a different question. Are you at all engaged with SETI? No. I'm an aspiring physicist. Do you have any useful tips on how you earned your doctoral degree? Find a professor, like your doctoral supervisor, that you get along with, because you're going to be working with them for a while. Where did you go for your PhD? I'm not telling. Is there a limit to the size of a particle? Particles, as we typically define them, don't have a size. Do you believe in the theory that everything in the universe could be inside a black hole? No, and I think that one could actually prove that that's not possible. Essentially as a result of, well, at least that we don't have evidence that supports it, I should say. Will we ever be able to comprehend everything that is beyond our understanding at this point? That's a wild question to ask a person. Do you believe in the theory that everything in the universe could be... Oh, I already answered that. Sorry. Can a 1,000-piece puzzle be completed by being shaken up if you try 5 times? I mean, in principle, it can be. It's just the probability is very low. How do you think quantum computers will be able to use quantum physics to work in the future? They're already working. Why does E equals mc squared? I get the energy equivalence, but why c squared? That's just what the math says. That's just what happens. And I mean, like, C doesn't have anything to do with light. It's just it is the speed that is, it's kind of like the only universal reference speed we have. So if there was going to be a speed there, then it's not surprising that it's that speed. Do you believe in the supremacy of the horizontal stream? I do. More people should come to the horizontal stream. By the way, I should show for myself. So currently I have 2 YouTube channels. There's the main YouTube channel, just at Blitz PhD. It's the normal one. You guys probably all know of it. However, there's also a new YouTube channel where all of my debunking stuff is going to go, all of the debate clips are going to go, and all of my horizontal live streams are going to go. So if you want to watch in horizontal, or if you want to go watch my debunking stuff, or if you want to go watch the live stream clips, make sure to go subscribe there and just watch stuff. I'm trying to get that channel monetized ASAP, and I currently need, I think, 3,000 total watch hours, which might take a bit unless you guys go and you watch stuff. So go watch the live streams, go watch the horizontal stuff, because then that counts for live stream watchers. So yeah, go there. You can watch it on your TV. What are your main Overwatch characters? So in Overwatch 1, I mained almost exclusively Widowmaker, and then I picked up Mei in the latter years of Overwatch 1. So I had like 3,500 hours on Widowmaker, 900 hours on Mei. I played a lot of Overwatch. It was my only game for like 10 years. Then Overwatch 2 came out. Widowmaker kind of sucks. I like Mei more anyway, so I play more Mei. However, recently I picked up Zenyatta in Stadium, and I've been doing that. Zenyatta in Stadium is a blast. I just want you to know, I think it's really awesome that you have your PhD. Well, I appreciate that. Yeah, all you verts, go watch the horizontal stream. From Roy with the 40, I think those are Indian rupees. Tell me the approach and resources for math tools to learn. Khan Academy, MIT OpenCourseWare are both good sources. You play Marvel Rivals? I did for a bit. I haven't played it in a while, but when I was playing Magic. What is your Overwatch main and rank? Oh, so I don't really play competitive, like normal competitive Overwatch anymore. When I was like solidly in high gold down to low diamond, depending on how frequently and how tryhardy I was. Although I think that I played some support round, some competitive games of support, some competitive rounds in Overwatch, normal competitive, on support recently, and it's possible I might place diamond on that account, or on that role. Was it extremely hard to get your PhD? Please stop spamming, Lorenzo. I'm gonna have to mute you. Spam is not appreciated. Has there been any more progress in our understanding of dark matter, dark energy? Yeah, of course there's progress. There's always progress. It depends on what you're asking for, right? Is JWST observations changing any paradigm? It's changing our paradigms of galaxy formation. Definitely. What do you like most about yourself? I don't know. I'm smart. How about that? That I'm smart. Would it be possible to see past the Great Attractor? Look, the reason why we can't see what the Great Attractor is because our galaxy is in the way, right? There's just stuff in the way. We can't see through it. The galaxy has stuff in it, and the Great Attractor is on the other side. Dr. Blitz, search up the modal ontological argument. I'm familiar with the modal ontological argument. I think it's very weak. Do you think everything that ever is because of random events? No, I don't think that there's anything. I lean towards there's nothing random at all. Since mass energy conservation is not true at the level of the cosmos, does that imply that the universe could have a beginning? Maybe, but it's not really. Well, okay, it doesn't imply that, no. Now, maybe the universe does have a beginning, but that seems like it's unrelated. How can light be measured as c with every inertial observer? You're asking why the universe is the way it is? That's a fact of our universe. Dr. Blitz, what's your critique on the modal ontological argument? That's not for this live stream. This live stream is about physics. Could the expansion of space itself ever reach a point where general relativity no longer defines what distance or time even mean? Well, look, if you have spacetime, then you still have a definition of both distances and durations. Both of them are there. Majesty of Reason recently had a paper arguing that the modal ontological argument ends up being a weak argument for atheism. Pretty funny stuff. Yeah, I've seen that. What would be the best approach to a space-time GPS? Well, I actually made a video about this not so long ago. It's called the what's it called? It's essentially a list of 300 quasars that you can essentially locate yourself in the universe by figuring out where those quasars where those quasars appear to be in your sky. And I think it's called the let me just Google it. That's right. It's the International Celestial Reference System. That's what it's called. So, and I made a video on it. It's pretty neat. You could always figure out where you are within a few light years by using the International Celestial Reference Frame. Thoughts on relational quantum mechanics? I don't know a lot about it. I probably don't know enough about it to have a strong opinion on it. Perhaps I should have asked if matter energy could go to zero at some time in the past. Matter and energy aren't the same thing. You're thinking about mass energy. And no, like we kind of don't expect that the universe ever had a zero energy in any sense that was useful. Anyway, so I've been on for about an hour and 45 minutes. I do have a meeting in about half an hour and I need to go get some coffee and eat a snack before that. So I'm going to end the live stream here, but thank you guys all so much for being here, for enjoying. And we'll be back tomorrow for some more regularly scheduled debate content. And remember, if you're 18 plus, go join the Discord. You can ask me questions there. You can talk with like-minded people. Discord links in the description and my link tree, all of those places. And make sure to go subscribe to my new YouTube channel. It's at Dr. Blitz Debunks on YouTube. That's where all the debunking stuff will be on YouTube. Up until now, there was no debunking stuff on YouTube, so go watch. Go subscribe. All right, take care, everybody.